All right, thanks for joining if you're here. Optional video examples. Use the fundamental identities to identify the remaining trig functions of theta. So we have cosecant theta equals 2 and tangent theta equals root 3 over 3. Now, if cosecant is equal to 2, well, cosecant is a sine function. So that means, oops, sorry, that pen is a little bit larger than what I want. That means that the sine of theta is always 1 over the cosecant of theta. So that would be 1 over 2, or just 1/2. The tangent of theta is root 3 over 3. That means that the cotangent of theta is equal to, and again, that's 1 over tangent theta. 1 over tangent theta is going to give me 1 over root 3 over 3, which is 3 over root 3. And when you rationalize that, this is a 3, sorry, you get 3 root 3 over 3, which is root 3. That's sort of a longer process than what you'd necessarily need to do, but I tried to show every step there. So then you're looking and you're like, well, what about like cosine and sine? I'm sorry, not sine, we have sine. Cosine and secant. For cosine and secant, you have some options. You could draw a right triangle. That's how we did things in chapter 4 way back when. You could also remember that tangent is really sine over cosine. So tangent is sine theta over cosine theta. Now I know that sine of theta is equal to 1/2. So this is 1/2 over cosine theta equals, and I know that tangent is root 3 over 3. So you're sort of solving this equation. 1/2 over cosine theta equals root 3 over 3. You can multiply by cosine on both sides. So you get 1/2 equals root 3 over 3 cosine theta. I'm going to multiply here by the reciprocal. So I'm going to multiply by 3 over root 3 and give me 3 over root 2 root 3 equals cosine theta. And if I rationalize that, I get 3 root 3 over 6, which is root 3 over 2 equals cosine theta. Now you might be thinking like, whoa, I did not follow most of what happened. Don't worry, that's perfectly fine. I would never really expect that you would do this problem in this way. It's just a cool thing that you could do. So again, just walking through it, what I did is said, well, tangent is sine over cosine. Sine is 1/2, so it's 1/2 over cosine. And that's equal to tangent, which I knew was root 3 over 3. And then I solved that equation for cosine. But what you really, just should do is use that right triangle trig that we know and say, well, if sine is 1/2, sine is opposite over hypotenuse. And then just solve for this third side using Pythagorean theorem. I'd get root 3 here. So then the cosine of this angle is root 3 over 2. You're going to get the same thing. It's going to be a lot quicker. And this is totally just what we did in chapter 4. All right, so if I have sine of x equals 3/5, cosine of x equals negative 4/5, I can get some of those really quickly. And this one I could probably even do without the triangle. So if sine is 3/5, that means that cosecant x, where x is just an angle, same thing as theta, is equal to 5/3. Secant x is equal to negative 5/4. If I want tangent x is equal to sine over cosine. So that's going to give me tangent x equals negative 3/4, which means cotangent x is equal to negative 4/3. Here, all I did was canceled off these 5s. So this one, able to do without that triangle. The rest of what we cover in section 5.1 is verification questions or simplification questions. So this is a simplify question. I could tell because it says the word simplify, and also because there is no equal sign. A simplify question versus a verification question, they're arguably more difficult than each other. It depends on how well you're good at thinking about these. A simplify question, the problem is you don't always know that you're supposed to stop. There's supposed to be like a final answer, and you have to make sure that you get that specific final answer. A verification question, I've given you the answer. I'm just looking for the work that gets it. But that sometimes can be tougher because you might get a tougher question because of that. So tangent x, cosecant x. Going and thinking about all my identities that I know, the one that I know I'm not going to use is the Pythagorean identity. I know I'm not going to use the Pythagorean identity because that always involves something squared, and none of these are squared. So instead, I'm just going to start and say like, okay, well, tangent is sine x over cosine x. Cosecant is 1 over sine x. Well, this is pretty convenient because now the sine x over sine x can cancel, and I'm left with 1 over cosine x. 1 over cosine x, well, that's the same as just secant x. I can't simplify this any further, so I would leave that as my final answer. Sometimes with these questions, you're going to try something, like I tried rewriting tangent to sine over cosine, and cosecant is 1 over sine, and that may not work, or it might not help me. But, you got to be comfortable just erasing, starting over. If you're going to ask a question, like if you're going to be like, hey, Mr. Dybus, I don't know where I went wrong on this one, I need you to not have erased it so that I could see what you've done. Next, I have sine x cosine squared x minus sine x. So I do see that cosine squared. That's exciting. But I also see that there are two terms here, and they have something in common. They have a sine x. So I'm going to factor out that sine x. So what I'm left with in this first term is cosine squared x. And what I'm left with in this second term is just 1. Now, if I'm thinking about this cosine squared x, what I usually do is I just write off to the side cosine squared x minus 1. Well, I know that sine squared plus cosine squared equals 1. So if I were solving this to make sure I had cosine squared minus 1, I'd have to subtract the 1 on both sides. So I'd have sine squared plus cosine squared minus 1 equals 0. And I'd have to subtract my sine squared on both sides. So I'd get cosine squared minus 1 equals negative sine squared. What this allows me now is just directly substitute because I have cosine squared minus 1, and here I know what cosine squared minus 1 is, negative sine squared. So now I would have, I'll go back to blue, sine x, negative sine squared x. So this will give me negative sine cubed x. An alternate way of thinking about this, if what I just did in pink was a little bit confusing, is just replace cosine squared. Again, using this same idea, cosine squared is equal to 1 minus sine squared. So if I take this problem from here, I would have sine x times, I'm replacing cosine squared with 1 minus sine squared. And all I replaced in this case was cosine squared. So I'd have this minus 1 still. The 1 minus 1 cancels, and I'm left with negative sine squared times sine, which gives me negative sine cubed. So same answer, just a slightly different approach with how you want to show that Pythagorean identity. All right, 1 minus cosine squared, I think that's psi, maybe phi, might be phi. Yeah, I think it's phi. So 1 minus cosine squared phi times cosecant phi. This sort of variable letter doesn't really matter. It just represents an angle. Here it's beta. But be comfortable seeing whatever it is. It's still talking about the same thing. So to start off, I see this cosine squared. I see that this is a 1 minus. And anytime I see a 1 and a trig function squared, I know I'm thinking like those Pythagorean theorems. Pythagorean identities. So again, I know sine squared plus cosine squared equals 1. So 1 minus cosine squared, if I subtracted this over, would be equal to sine squared. That means that I could rewrite this. That was a terrible little, there we go. Nope. There we go. I could rewrite that piece as just sine squared times cosecant. Cosecant I could rewrite as 1 over sine. So this becomes sine squared times 1 over sine. And my squared over sine can cancel. So I'm left with just sine. So all of that is just a way of simplifying this down to sine. Again, I don't always know where I'm supposed to stop, but you want to have something that's sort of broken down to the smallest number of terms and can't be simplified any further. Cosine squared beta times secant squared beta minus 1. So again, I see this and I'm thinking there's a Pythagorean theorem here. Our Pythagorean theorem says 1 plus tangent squared equals secant squared. So if I subtracted that 1, I would get tangent squared equals secant squared minus 1. So I could rewrite this as tangent squared times cosine. Now I still see that there's these squareds, but I don't have 1 anymore. So what I'm going to redo or do now is rewrite tangent. So this is cosine squared beta times tangent is sine squared over cosine squared. So my cosine squared over cosine squared could cancel, and I'm left with just sine squared beta. So this is all I'm going to cover in terms of simplification. Now we go into verification. Verification, the sort of cool thing about a verification question is you know what the answer has to be, cotangent theta, and everything that you have to do with this problem just becomes a game of like, how am I going to get cotangent theta? So in a question like this, there's nothing that's squared, which means I'm not going to simplify anything over here first. I'm probably just going to FOIL this out, multiply this out. One thing too, if you don't remember from section 4.3, verification questions, you're not going to touch this piece. So in a verification question, you are not going to add, subtract, multiply to both sides. You are simply going to work with the left side or the right side, and only that side of the equation. The other side is just the answer. It's what you're supposed to be getting. So if I multiply this out, I'm going to get secant theta, cosecant theta, theta. So I did these two. And then I'll have secant theta. Then I'll have negative tangent theta, cosecant theta. And last, a negative tangent theta. So all I did there was just multiplied things out. What I usually do then is sort of look to rewrite some of this stuff. So this is 1 over cosine times 1 over sine plus 1 over cosine minus, this is sine over cosine times 1 over sine minus sine over cosine. And if I'm going to cancel things, I want to look at individual terms. So here's one term, I can't cancel anything. Here's a term, I can cancel the sine over sine. So this would give me minus 1 over cosine. You could see this 1 over cosine. And now this positive 1 over cosine, negative 1 over cosine can cancel. So what I'm left with is 1 over cosine theta, sine theta. That's coming from right here. I canceled out all of this, so minus sine theta over cosine theta. When I look at this, I see that I am trying to get this down to one term, which means I'm probably going to want to combine these two things so that I can create just one term. So if I want to combine them, they're fractions, and what I need to combine fractions is a common denominator. So I'm going to have to multiply by sign on top and bottom. That gives me 1 over cosine theta sine theta minus sine squared theta over cosine theta sine theta. Because these fractions are the same denominator, I can subtract the numerator, 1 minus sine squared theta over cosine theta sine theta. 1 minus sine squared theta, that again is a Pythagorean identity. It comes from that sine squared plus cosine squared equals 1. So if I subtracted the sine squared to get this, I would have cosine squared on top. Now my cosine squared over cosine can cancel. So I'm left with just cosine theta over sine theta, which gives me cotangent theta. Which is great because, as you can see, that is what I was supposed to get. And that's how I know I'm going to stop there. Some of these problems, every once in a while, you get a question where you could go further, but you don't need to because it says to just get to this. So I got into that. You could tell there's a lot of work that goes into this. Verification questions sometimes are short, sometimes are moderately long, and sometimes you get ones that are really pretty long and are just sort of a puzzle. You know, nothing that I did here is particularly difficult. All I did was foiled. You guys have been able to foil for years now. Rewrote trig identities as just reciprocals. That sort of new, but not terrible. Got a common denominator of a fraction and then subtracted the fraction. And then here's the piece that's new. Oh, 1 minus sine squared theta, that's cosine squared theta. That's what was new in this problem. That one little piece. All the rest of that, that's just algebra, how to multiply fractions, add fractions, subtract fractions, how to multiply things without numbers. All right, 1 minus sine squared x over 1 minus cosine x is equal to negative cosine x. So how wonderful, I gave you the answer. You know, just do all the work that gets me that. So I'm looking at this 1 minus sine squared x over 1 minus cosine x. A lot of different approaches that you could take. I'm going to try and, again, get this down to one term. So I'm going to actually rewrite this 1 as 1 minus cosine x over 1 minus cosine x minus the rest of this, sine squared x over 1 minus cosine x. And all that's really allowing me to do is now combine these fractions. So this becomes 1 minus cosine x minus sine squared x over 1 minus cosine x. Sort of reformatting this right here, this is the same as just negative cosine x plus 1 minus sine squared x. All I did was move the 1 over here, because now if I look at just specifically this piece, 1 minus sine squared x, thinking about that Pythagorean identity, that's the same as cosine squared x. So I have negative cosine x plus cosine squared x over 1 minus cosine x. Well, looking at that numerator, I've got two terms, and I can take cosine out of them. And again, I'm going to sort of restructure this. So I'm going to take cosine out. It's a terrible cosine. What I'm left with, from this term, I would be left with cosine. From this term, I would be left with a negative 1. I just flip-flopped those two. All over 1 minus cosine x. Now you're looking at this and you're like, ooh, that really, really, really looks like it wants to cancel. Because you've got the cosine, you've got the 1, you've got the minus, but you're subtracting 1 here, you're subtracting cosine here. But that's actually an easy fix that you don't always think of. Some of you might have, but not everybody will. If I factor a -1 out of this and made this negative cosine x, that would make the cosine the negative and the -1 the positive. So again, I just factored -1 out of this binomial. And my 1 minus cosine can cancel. So I'm left with negative cosine x, which again is great. That's exactly what I needed to get. I took a long and convoluted route. By no means is this the only way. There have been problems where I do it one way and maybe it takes 5 steps, and then a student will come up and be like, hey, I did this in only 4 steps, and I'll look over those steps and be like, yeah, it's just not the way I thought about it. So there's absolutely more than one way that you could do these. Feel free to do them that way. All you have to do is make sure that every single thing that you've done, every substitution, every rewrite is sound and valid, meaning it's something that is true and it's something that algebraically you are allowed to do. Sometimes people do get to the right answer, but they make like 3 mistakes along the way, or even they just make 1 mistake along the way. But they made a mistake and then sort of like changed things later on to deal with it. That it's not actually verifying it then, because you've done things that are not true. All right, last one. 1 plus cosecant x over cotangent x plus cosine x is equal to secant x. So a lot of fractions going on here. What I like to do is rewrite all these things, which is going to look ugly, but 1 plus 1 over sine over cotangent is cosine over sine. And cosine is just cosine if you wanted cosine over 1. So I've rewritten all 4 of these terms, with the exception of 1. What I've realized is 2 of them have a denominator of sine. So what I'm going to do is get everything to have a denominator of sine. So I'll multiply by sine over sine here, and I'll multiply by sine over sine here. Now I'm not multiplying to the whole numerator and whole denominator, just to these individual terms to rewrite them. So now this becomes sine x over sine x plus 1 over sine x over cosine x over sine x plus cosine x sine x over sine x. Now you do not want to cancel these, or you do not want to cancel these. What you want to do is just cancel now all of the sine x's. And if you're thinking about like, whoa, Mr. Davis, why can I do that? If we just take a little side note here, if I added these, this would become sine x plus 1 over sine x over cosine x plus cosine x sine x over sine x. When you're dividing by a fraction, you multiply by the reciprocal. So this would become sine x plus 1 over sine x times sine x over cosine x plus cosine x sine x. And those sine x's would cancel. So technically, can you cancel these? Algebraically, it's a little bit loose, like there is this intermediate step. But for the sake of space, when you see this, feel free to cancel those right away. Just have the understanding of why you can do that. So anyways, this becomes sine x plus 1 over cosine x plus cosine x sine x. Right away down here, I see that I could take a cosine x out. So this is going to become sine x plus 1 over cosine x 1 plus sine x. These can cancel because sine x plus 1 and 1 plus sine x, those are the same thing, not like subtraction where the order is important. So I'm left with 1 over cosine x, which is secant x. So there's a verification question. Again, simplifying, a lot of times people like the simplifying questions better, even though they don't know what the answer is supposed to be. Verification, you usually get the tougher questions. By design, you get the tougher questions, but you get the answer. So you know where you're supposed to be going. And sometimes you can use that, or you can usually use that to guide your thought process. All right, get to some of that book work. See if you can do especially some of those verification, simplification questions. Jot down if you have any questions on your own to ask before we get started.